Hello guys, welcome to today's lecture. So as promised, I'll be doing online lectures. Today, let's do something interesting. So we talked about how can we deal with the data, right? And like using pandas, using Python to deal with the data, either processing, either expecting that. So far, our data are like given to you, but a lot of times you will be interested in finding your own data. So one technique is called web scraping. Web scraping is literally automatically taking data from the internet. Second. Okay. So in the internet, the format is HTML. It's the language of the script. So compared to TXT, so this is TXT file. TXT file is just text. So like A, B, C, 1, 2, 3, those letters, those symbols together, no structure. But HTML is text with structure. Okay? So how kind of structure we have? You got a structure of blocks. So that means not PowerPoint, Paint. Let me do this for you. So imagine that you have a structure like this. Let me paint it. You have yeah, for example, brush, can I write something? Yes. Let's say um this is a book, right? And in the book there is chapters. So this first block is chapter 1, and then you got chapter 2 as well. And inside chapters, you got pages. So this is the first page. Let me use different colors for chapters. Seconds. So chapters, let's say you're in blue. Why not? These are chapter 1. This is chapter 2. And inside chapters, you got pages, right? So this is page 1. This is page 2. And inside pages, you got more structures. So in the book, you want to say something like the title of the book, right? And chapter 1, it can be the title of chapter 1, it can be the first chapter. If you are in those structures, TXT file, how would you represent it in TXT file? So in TXT file, you just, or like in Word, for example, you can just have bigger text, right, and smaller text. You can visually, oops, sorry, or should I say structure are shown visually by making the text bigger with a different font. But for HTML, the structure are shown explicitly. So let me show you how it's done. So the structure is like this. You got the beginning of the book, right? The book begins. And once the book begins, what's the following? Let me think. Yeah, the chapter 1, so the title of the book. And then you got begin of chapter 1. Inside of chapter 1, you got something. Oh, just ignore it. And inside chapter 1, before chapter 1 finish, you have to begin page 1 and then end the page 1. And later you got begin page 2, end page 2. And then you got end of chapter 1. So the chapter 1 finished like this. And then you got chapter 2 that starts, and then chapter 2 that ends. And at the end, the book ends. You see, this is the structure, and this structure is the same or should I say, it's the depiction of my diagrams to the left. So in HTML, everything is with structure. And to show the beginning of the book, it is written this way. You have a starting bracket, you have the book, you have the ending bracket. This is the beginning of the book. The end of the book will be like this, but with a slash. At the same way, the beginning of the chapter is chap with bracket, and the end is ending chap with the bracket. So this thing can be represented this way. So that's translated into HTML. Beginning of book is book. You got the title, the book, the title, right? Since this is just text, not a block, you don't get the bracket. And then you start chapter 1. And inside chapter 1, you start paragraph 1, you end paragraph 1, page, whatever. So you start page 1, you end page 1, like here. You start page 2, you end page 2, like there. And then you end chapter 1. So it's bracket slash chapter 1. After that, you got chapter 2. And followed by that, something in the middle, you end chapter 2, and then you end the book. Voila. This is a analogy of how HTML works. You got those, you see those complicated signs, but you can break up into the beginning of and the end. So break them up into beginning and end of blocks if you want. So the block of chapter, block of paragraphs. So far, so good. So let's see what a page can be. I'll show you this page. This was one of my projects that I did before that I scraped from the international data. So once you enter this URL, you see this is Environmental Performance Index for NGA, I think it's Nigeria country. So this is a web page, okay? You got many information here. And your objective, your goal is to get this table without copy pasting every single number. And maybe you got, not maybe, you got more than 100 countries in the world. In case your research, you need to get the country data, you will have to go to this page one by one, copy paste into Excel, whatever. That takes time. And you see the, maybe even worse, it's not taking time, is this data can change based on the time. Imagine this is not a fixed country data, but a stock market that every day you want to get the value of those stocks. Well, it changes every time, every day, then it is very confusing, but it's very time consuming that you do it every day. So you want to make it automatic, and that's what web scraping come into place. Anyways, so you got your URL, meaning the website, HTTPS, www, something like that. This is the URL. In the browser, once you enter the URL, you see this text. And actually, this is a visualization for you. What is behind the browser is it is translating a HTML document. So I suppose if you do F12, you got this developer tools. And I suppose you can see, yes, if you go to, this is a Edge browser. If you're using Chrome or another browser, this is the developer tool. I just want to show you this. This is HTML. Now you see bracket HTML, some parameters. So one thing I didn't mention. So book, maybe this book is with a type. The type is fiction. You can have the parameter inside the defining bracket. And chapter one maybe ID is introduction. You can have the parameters inside this bracket, even more structured. So this is the beginning of HTML. Imagine it's like a book, right? The beginning of the book. And then you got head, the close of head. Body, the close of body. So the body is actually inside the whole, englobing the whole thing. So you see that div is the division. Let me show you something. So div is the division. You got the style. You got some script. What specifically, what's the type of the bracket is not, uh, I won't say it's not important, but it's the same idea that it's a component of the HTML, right? So you have this file in web scraping in the course material. If you go to here and go to web scraping, you got this, and you can go to File, Upload Notebook, and you click Upload. You browse it and you click on this so that the file can be uploaded this way. For web scraping, we need two packages principally. Requests. Request make you get the information. And beautiful soup make information easy to access. So you already have the information, more structured. The information become more structured. Okay? So let's go through a first step. We have the URL like this. No problem. Let's execute it. I'm waiting for my Python to connect. Okay. So let's import the package. The syntax is like that. And you make a HTTP GET request to fetch the page content. Let me execute it. When you don't know how it works, just let it go. So we define a variable called HTML content. What does it look like? Well, it looks like this. A very long HTML. What type is it? It is a byte string. It looks like a string, but it's a byte. But most importantly, it contains the information. What information? You see this table, EPI table, biodiversity, blah, blah, blah. You got this number. So these informations, you see 28.3, 27.8. They are hidden inside this complex structure, but all the information, all the data are inside. So let's figure out how can we get this data. But first, we have connected to the internet and we get the data. For example, we can take a look at this. We print the first 300 characters or 200 characters. This is HTML. So if we look at the HTML content, you see a little brackets. This is called a tag. As I already mentioned, this thing, this is a tag. And HTML are like this. And next step, we will use the beautiful soup, the other package, so that our content are more easily understood. And in soup, we can use several methods. Let me use this. One method is called find all or find. I'll use find all more often. Find all. So when you have a structure, a soup is like a HTML text, the text with structure, right? Since this text has structure, you can click on find all. For example, if I say my book is like that, okay, I can do book dot find all, and I want to find what? Chapter 1. I want to find chapter 1. It will give a list containing all the matches. This is how you use find all. I'll give you right in hand example here. Let's take a look at the soup. You see, the soup has so many complicated things, right? Let's take an example of the class we see. We have TR, we have TD, right? So what happens if I want to find all the TR? We can make rows equals find all TR. And this will return a list. Because find all, you are potentially getting through multiple possibilities. So everything, it gets a match, it gets returned into the list here. Let's take a look at the first 5 elements. So you see the first 5 from the zeroth element, TR class. Anyway, it's a TR tag. And inside this TR, you got a lot of things until you find the end of TR. So this is the first chunk, right? It's like this is the first chapter. Inside that, you got the first sentence, the first page, the second page, third page, fourth page. And each time you see the fourth page, you got the beginning of fourth page, the content of what's inside, and then the end of it. And those pages are contained in the chapter. So that's how you can get access to it. And let's say you want, let's go through it. Next. So let's get a goal here. For example, I want to get the information from all the EPI, right? This table. I want to get this row, EPI, whatever index, 162, 28, 30, minus 6.1. So how would you get that? First of all, using the development tool, you can scroll over things to find where this information is from. So I think this is from the body. So let's take a look at here. You see, when I roll over the body, the left-hand side, all this part get covered. So it means my information is part in this chunk, in this chapter. Okay. So if I click on this, you get into, so first division, second, third. Oh, you see, when I scroll over the fourth one, I see my left-hand side covered. So it means my information are inside. So let's click inside. Scroll over, oh, I see main. So it should be inside here. Again, let me go into even more. I see when I scroll over this division, it's covered. Go ahead, go ahead, go ahead. Oh, it's here. Let's continue. Go ahead. It is inside. I don't care about what's inside, what's so many parameters. What I care is where to find these information. So I scroll over again. Here, here, oh, here. But I get one weird thing is that it didn't cover all the way to the end, so I'm a bit skeptical. I'm a little bit skeptical, but let's try. Or the other way to work around is just to look for the information. For example, if I search over 162, let me see if I can do that. 33.3. Let's search for this. Oh, I found it. I don't know where I am, but it seems like this number 33.3 is inside the TD, which is inside the TR. So that's why I wanted to search over TR. I search over TR here. Okay. No worries. So we got the TR here. Let's get more idea about the structure here. So I see TR, component, rank, EPI score, 10-year change. What does that represent? Let me close this. Component, rank, EPI score. So TR is a table rule. This is the first row here. Let me go to the next TR. This is EPI. So we see it's EPI 162.28.3. What do we have this? 162.28.3 minus 6. Okay, we're getting interesting here. What is the next TR? We got ecosystem vitality 150.33.3. Well, it seems we are getting the data here. So let's do something more. Wait a second. Well, this is actually the way we extracted the link here. I'll do it again so that you see how it's done. So if we do again, so rows, how many TR are there? I can do length to show that. So 177 rows. And we just see that if we get the first 5 rows, what do we have? Takes a bit time. You see this. And of course, the first one or the zeroth one is without the data, right? So let's look at from the first one. So exclude the zeroth, just starting from the one. You got the data here. Let's get an admission here. Let's say I want to get the rank, the list of rank. Okay. So how would you do that? I will do this. So how can I get this number 162? My question will be how to get the number 162 here. Well, it's inside the TR, right? So if I go to rows 1, I got a TR. Inside, we got several TD. How can I access the TD here? I can do find all TD. So here I will have now let me draw it. So now what do we have? We got one TR object. Inside you got several TD objects, TD components, right? So when I do rows 1, or should I go? Let me go back a little bit. Rows, we find all TR. So we find the first TR, the second TR, etc. What we have is rows is a list of TR. We got a list of TR. But what we know, what we want is not TR, we want TD. So let's focus our attention to one single TR at a time. So let's focus our attention to TR. So that's only care about the TR. So the first one. So this TR is rows bracket 1 because it's not the 0th one, it's the first one. That's why I want to say, okay, let's look at our, let's call it first row, okay? So it's rows bracket 1. And first row should be a TR object. And how can you get the TD inside this TR object? Well, we can use find TD. So this TD. If we use find all of TD, well, what does it return? It will look into the TR. It will give you this TD, this TD, this. You see the TD here. Let's say you have three of them. You got TD, TD, and TD. And they will return you as a list. So after you apply find all TD, you get a list of TD. Let's see if it's the case. So first row, if I do find all TD, you see is square bracket. So in Python, it's a list. Let's call it list of TD. And list of TD, what is the data type? The data type, sorry, a data type. It's a result set, well, almost a list if you want. And you can get the length of that is 4. You got 4 instances of TD inside. And what is 162? Is it in the 0th element or the first element? It should be the first element, right? So if you go to here, list of TD, we look at the first element and we want to get the text out of it. If I do .txt text, you got 162. Okay? So this is how would you do with the first row. But we don't want this first row only. We want also the second row, right? So maybe you will do row equals 2 for the second row. It's 33.3. Is it the case? Wait a second. I'm a bit surprised it's not 162. Wait a second. So this is 162. And if we go back to rows, this is the TR here. And the next row, we got this. So let's inspect the next row. You got 115. Ah, I see. This is the second rule, right? But inside the second rule, you go to first row, second, third, fourth. The information you want is always at the first position. So this first actually doesn't change. So if you do this, you got 150. If you do it at the 3, you got 121. This is indeed 162, 150, 121, the information you want to do. So now you can repeat almost the same thing, but each time there's one single number that will change. In this case, you will do a for loop. So let's make it, instead of 1 and 2, we make it I. And this is not the first row, it is the, I will say the current row. Current row. So if I do for I in range, let's start from 1 and let's stop at 5, just to see. And let's print out the text here. 162, 150, 121, 91. Oh, great. We got the information. Why not put the information inside a list? So if I make it, the rank is the empty list. And instead of printing it out, each time I will do rank.append. I will have this text stored inside the list. And I print the list. You see, I got the information. If you want, this is always a number if we are sure about that. And instead of a string of numbers, let's make it an integer. So int of this thing. You see, it becomes a list of integers. So now you just have to count to which point you want to get along and to get this table. So far, so good. Let's do something more. So we got the way to grab a line or a row of information. What if we want to get all the information here? This is look at table, right? So in the table, we may want a pandas data frame. So let's try it this way. Import pandas as PD. By the way, we've always created or imported data set, but we can create a new data set using pd.dataframe, and we can specify what columns we want to have. So the columns I want the components. What else? Rank. What else? EPI score. What else? 10-year change. 10-year change. This will be our data frame. Let's look at DF. For now, there's nothing yet, right? So let's take a look at how can we populate our DF. So again, let's go back to here, superfine all TR. TR is the chapter that contains all the important informations here. So rows, if I do rows again and up to 5. First, we don't want the 0th row. It's just the title. It doesn't have the information. So let's start from 1. You got EPI 162. This is indeed what you want, right? So let's look at the first row again, equals rows 1. And let's take a look at first row. You see, first row, you got different TD here. So what do we want? I want for each row. For each row, what do I want? I will find all TD inside because I need the information inside. And each time, it always be a list of 4 TDs. What first, the 0th TD, first TD, second TD, and third TD. And the 0th TD is the component. First TD is the rank. And the third TD is EPI score. The fourth TD is 10-year change. Okay, so let's do this. So first row, let's find all TD. All right? So let's call it all TDs, the list of TD. And we want the 0th is the component. So components will be 0. So component will be list TD 0.txt. The rank will be the first one. The EPI score will be the second one. And the 10-year change will be the third one, right? And instead of text, I know that component is a string. Rank is a integer, so let's make it int. And score value are float, so let's make it a float. 10-year change is also a float, so that the data types are okay, right? Okay, so this is from our first row. And how can we populate the data frame? Let's try if we can work this way. 0 component. In fact, in defining the data frame, we need to specify, I think it's called shape. Let's say we want a shape of 100 rows and 1, 2, 3, 4, 4 columns. Would it work? It's not the shape. It's called dimension, or it's called dim. Let me see. Wait a second. Sorry, I forgot. I didn't usually do data weight this way. Please wait a second. Well, why not ask ChatGPT? Okay, we can specify our index like this, and then columns like this. Let's take this. So instead, let's do it this way. So instead just index equals range 100. I think that will work. Okay, sorry about that. But now our data frame has the values already and the number of rows that is expected. Now what we can do is, well, we want our, why not make our index starting? No, it's okay. Yeah, let's make our index starting from 1. So df start from 1. It's a bit easier to work with like this way, right? And our component, I want to put it here. How can I access that? I can say df dot location. And what is the row? The row index is 1. And for the component, I want it to equals the component. So actually this. And if I do this, after I do df, you see the value has been updated. Let's do it similarly for rank, EPI score, and 10-year change. EPI score, do I call the EPI score? Yes. EPI score is this thing. And df location 1, 10-year change equals this. And let's look at df again. So I don't need this text anymore. You see, we have successfully created a data frame that contains the information that we get from the internet without copy pasting our internet information. You may say, yeah, okay, you did this so many efforts just for one rule. It's time consuming, it's not efficient. Well, actually in programming, because of loop, if you do know how to do it for one, you do know how to do it for a lot more. So instead of first rule, let's call it current rule. Nothing changes, but you see, always is the 1, right? When we're moving to the 2, you will see that this 1 will be replaced by 2. So let's make it I. And let's put things in the loop here. So I will replace all the things with the I. And I will say for I in range, let's try what? From 1 to 10. just for now to see. So current row is the row number I. And I get all the TDs. For that row, I enter the values as expected, and I go df. We have a problem. It's a value error, could not convert string to float NA. Okay, cannot convert string to float NA. So maybe sometimes this is a NA value, or we will enter more NA values later on. How can we do that? We can use the if condition, right? Oh, there are better ways to do that, but let me show you an easy solution. So we can check. If it's a NA, what do we do? I think in Python you can do, let me just, wait a second, let me just pass it. In Python, you can do a float into NaN. Let me comment this out. You are allowed to do this, right? It's rendered as a NaN value. So if it's the case, I will make it EPI score equals float of NaN. Otherwise, the EPI score is the float, so that I'm sure I'm not entering a NaN value. And then in this case, I can just safely make it EPI score. Depending on the case, it can be either non-applicable missing value or the text. Same way here. Same way here, I can detect whether they are missing values and give it out like this. So you see in Python programming, sometimes you will encounter mistakes or errors. You just need to identify what's happening. As you program more, you will know better and better. And then you can fix them one by one just by tweaking the code a little bit more. But you get the central idea first, and then you fix those little mistakes. So let's look at it. You see df, and let's do it head of 10. You see, just by writing a loop, it takes a lot of effort to do it in one row. But imagine your data have tens of thousands of rows. Well, this code, what you want to change is from 10, you change it to 30. You do 30 rows in one click like this. So that's the benefit of programming language. Of course, when your range goes higher, it will eventually runs into an issue because you don't have so many rows. So you need to decide how many rows you have. But that's the global idea of how would you scrap a data into a data frame. Below are kind of the same idea, or that was the result I get from different parts. Of course, later you can get more pages link. Let me just show you. So this was the page for one country, Nigeria, right? Imagine you want to get more countries. I suppose if you type USA, yeah, you get a different country and different values. In case you need different values, how would you do that? So first, you need to know how many pages are there. So it can be here, can be USA or different acronyms. So let's get a list of acronyms. And how would you get that? Well, you see here, country. If you have this view country details, you click on that, you should have the link to get access to every country. So the link has to be hidden inside this selection list. So let's look for the word view country. Oh, let's see how do I did that. Oh, let's do it all around this. Okay. View country details. If I go to the developer tool again, you can click on F12 to get it. If you type view country details, got an H3, and inside it, what do we have? Form action, division. Let's see, what do we have? You see, the reason I'm jumping a little bit, the reason this text has been provided already, it was because you go to the developer tool and you look for the place to access them. So let's see how many access we have. You see that you got all the options, values, country, Afghanistan, Albania, something like that. And before that, you got this country slash triple letters, EPI. So if you get the triple letters, you can actually access to the URL because they are just the same URL except the triple letters that are changed. So if we get to this select class and all these options, we should have all the URLs. So let's look at options. I got the option like this, and it's inside the parameter value. Let's look at the first EPI. Oh, you got EPI. So EPI, this is not what you want. You got the components, right? So either you can select by components or select by country. It should be followed later. Okay, yeah, this is coming from different EPI, but the idea is the same. If you want to grab these triple letters, what you can do is you look at this options and you select the value of it, only the three last letters. Let's look at it. So for example, options 1, we got this EPI. So how can I get this? I can use bracket value. This is to access the parameter here. If I do this, I have the string of that value. So what do I want is the value, but only the three last letters. So I can do this, comma, -3. So -3 onwards. Only the last three values, I got the API. I can do this for the first, I can do it for the second as well. So that's why I create a list. For all these options, I take these X values. You see the same thing here. So instead of just the first one, I'll make it the first, second, third. So X in options like this, X bracket value bracket -3 onwards, and you make it store inside the try list. And now you got all the trigrams, the triple letters. So how can you get the URL? You can create a list. This is called an F string. So for example, I can type, my name is Yue, right? I can say my name is, and do the name I want. I just put it in big brackets. Nice to meet you. This is a string here, but it doesn't automatically change the value unless you put an F before then Python knows that between those big curly brackets, you are supposed to replace the value with the value you want. So now you replace with the value of the variable. It becomes my name is Yue, nice to meet you. So now, how can we get all the URLs? You have the component like this, slash different letters, right? So just like that, you can be my name is Yue. If you change name to otherwise, my name is Yeseg. Nice to meet you. You can change the value here. So I can change the value here for try in tries. So it will get all the trigrams value. So now you got all the URLs and you know how to scrape one. If you loop over it, you can scrape over different URLs. Below are the examples, but the idea stays the same. And I think I'll stop here. Thank you for watching.